Hi everyone, welcome back to our Unity Roguelite tutorial series. In this episode, we're diving into the world of enemy AI by creating a powerful, flexible finite state machine. Finite state machines are an essential tool for structuring complex behaviors into simple, modular states, perfect for making your AI dynamic and engaging. By the end of this video, you'll know how to build a reusable finite state machine framework, implement 3 core enemy behaviors such as patrol, chase, and attack, and set up a scalable system that makes adding new behaviors really easy. Whether you're a total beginner or you're looking to enhance your AI skills, this tutorial has something for you. Are you ready to bring your enemies to life? Let's jump right in. So before we dive into code, let's quickly cover what a finite state machine is. In essence, a finite state machine consists of 3 things. It has states, which are discrete behaviors like patrolling or attacking. Then we have transitions, which are just the rules that help us know when we should transition from one state to another. And finally, we have state management, which is a system that will execute our current state and then also handle transitions to a new one. This makes finite state machines perfect for AI as they keep the behaviors modular and easy to manage. So let's go ahead and set up our framework. So first, I like to start out by planning my finite state machine in a flowchart, and I usually start by defining what states we're going to have for our enemy. So I've actually decided on 3 states. I've decided on a patrol state. In the patrol state, the enemy is going to move between waypoints. I have a chase state, and in this state, the enemy is going to chase the player until they are within attack range or the player can no longer be detected. And lastly, we have the attack state, which is going to be the state where the enemy attacks the player when the player is in attack range. So once we've decided on the states for a finite state machine, we'll need to decide how we're going to transition from one state to the next and which states will be connected. So first, we're going to transition from patrol to chase when our player is in detection range. So let's go ahead and add that transition. And then I'm going to add just a little text box here that lets us know. So player is detectable. All right. And we also need to make sure that our player is not within our attack range, because if it were, then we would go ahead and head to attack. So let's also say player is not in range or in attack range. So those are the things that we're going to look for before we transition to chase from our patrol. So the player must be detectable, and also the player is not within our attack range. Okay, so then let's go ahead and do chase to attack. So we'll transition from chase to attack when the player is detectable, but the player is also in attack range. Let's see, so instead of is not in attack range, we'll say is in attack range. Then we'll go ahead and transition from attack back to patrol if our player is no longer detectable and they're also no longer in attack range. So we'll just say is not detectable and is not in attack range. Right, so that gives our main loop here, but we should also be able to transition from chase back to patrol if our player no longer is detectable. So let's go ahead and add that one. And we'll drag down some text here. And we'll say player is not detectable, player is not in attack range, so that is that transition. And then we should also be able to transition from attack back to chase. Let's go ahead and add that one. So I'm going to move this text over so we can make sure we... Okay, so let's go ahead and add a new text here for this transition. So this one is player is detectable, but they are not in attack range. So we'll go from attack to chase. And then we're going to go ahead and also make a transition from attack, or from patrol to attack. You can go ahead and just add it like from here to like here, and then we'll just flip it around. So we'll go none, and then we'll add the arrow this way. So from patrol to attack. Make this just a little bit more visible there. There we go. So from patrol to attack, and we're going to do that when the player is detectable and is in attack range. So that means we've kind of skipped chase because like we have immediately already close enough detected and they're close enough to attack. Okay, so that is all of our transitions. So now that we have that defined, we can go ahead and start coding our finite state machine. And in our scripts folder, we're going to create a new folder, and we're going to call it AI. And then in our AI folder, we're going to go ahead and create a new C# script, but we're going to go ahead and go to scripting, and we're going to select empty C# script. And this is going to create an empty state for us to start in, since this script will not inherit from model behavior. This is actually going to be our state, and this state will define how a state works. So let's go ahead and create that. And then once we have it created, let's go ahead and open it up. All right, so now that we've got this open, let's go ahead and start coding our state. So first, this is going to be an abstract class because we're not going to use our state as a state. We're going to go ahead and create children classes that will tell us how that state is going to work. So we'll never have just a default state. We'll always be inheriting from here in order to define it. And every state should know who its owner is, because this will allow us to get like transform, our world position, any components that we might need to run that state off of our owner. So let's go ahead and add a protected variable here. And I'm going to make this a transform variable, and I'm going to call it owner. Okay, so let's go ahead and save that. And then let's create a constructor so we can set up our owner. So we'll say public state. And then we'll pass in our transform, and we'll call this owner as well. Then inside our constructor, we'll say this.owner equals owner. Okay, so now that we've got that, we can go ahead and determine how our state is going to work. So what I've done is add some abstract voids in here that will allow us to make sure that our children implement these. And we're going to have an enter state. So that is going to be a public abstract void. And we're going to call it enter. And when we enter a state, this is going to be the code that we run before we start updating our state. So any setup needed here is going to happen in our enter state. So if we need to get a component in order for us to be able to process our state properly, that's where we'll do it. And then we're going to go ahead and create a run or an execute. So say public abstract void execute. And this is going to run on update. So as we are running our state and we're calling update, we're going to process any of the code that's in here. And then we'll also create an exit function. And this is going to allow us to do any cleanup needed before we destroy the state and transition to a new one. So if we need to release anything from memory, or we need to delete some stuff out of the scene, that's going to be where we do it. Okay, so let's go ahead and create our state machine class, which will allow us to manage our states. So inside of our AI script folder, we're going to go ahead and create a new file. We're going to call it statemachine.cs. And in here, we're going to say public class, and then we're just call it state machine. And we're not going to inherit from anything because this is just going to run on the back end inside of our AI controller. All right, so this is going to be a backend class that's going to allow us to manage our states. So our AI controller doesn't have to worry about how this should work or how we're going to change states. We can just say change state, and our AI controller can be more specific to our enemy, but the state machine is going to be very generic in general, so we can use it on any AI controller. All right, so now we need to go ahead and define some things before we can actually get started on creating our state machine and running behaviors. So first we'll need to know what our current state is, so we can call those exit and enter functions and also update our state. So let's go ahead and say private, and then we'll just call this state, and we'll call it current state. Okay, so then we're also going to need a way to change between states. So we'll create a public void, and we'll call it change state. And this is going to take in a new state. And now we're going to call the exit function on our actual current state, so we can make sure that any cleanup or exit behaviors can be run before we go ahead and switch our state. So we'll say current state, And then at this point, it is possible that we have never set a current state before. So our current state could be null. So we're going to add a null check here before we call exit. Okay, now that we have exited our current state, we're going to go ahead and change our current state to our new state. So we'll say current state equals new state. And then lastly, we're going to call the enter state. And because we've set our current state here, we don't need to do the null check because we know it's not null because we've added a new state. So we'll go ahead and say create current state dot enter. And that is how we change our states. Next, let's go ahead and add an update function in here. And yes, I know that because we're not inheriting from mono behavior, we're not actually going to have the same functionality of this being called automatically by itself. But inside of our AI controller, we're going to go ahead and call this from our update function so that this will essentially function as an update function as well. So inside of our update function, let's go ahead and call the execute on our current state. And we did add a null check here because it is possible that we have never set our current state and this is going to run. So we need to make sure that this is not null before we call our execute. All right, so let's go ahead and save that, and this will give us our basic structure of our finite state machine and our states. So let's go ahead and create some state classes for the states that we defined earlier. So let's go into our folder, and we're going to create all of the classes that we're going to need. So we're going to create a patrol state, so patrol state.cs. And we're going to go ahead and just add our class in there. So say public class patrol state. And then this will inherit from state. And you'll see that we have this red underline here. And that's because we are using an abstract class. So let's go ahead and use our quick fix menu. So command period or control period on Windows and implement abstract class. And that's going to give us our enter, execute, and exit. Although that is not going to resolve our error because we do also need a constructor. So if you hover over here, we'll say there's no argument given that corresponds to the required parameter owner of state.state transform. So this is just saying that we're not passing the owner to our parent class. So we'll need to do that. So we'll use the quick fix menu again, and we'll generate our constructor. And that will remove all the errors from here. Okay, so let's go ahead and open up our folder again, and we'll create our chase state the same way. So we'll say chase state.cs. And I'm going to go ahead and copy my patrol state and paste it in here. And then we're just going to change this from patrol state to chase state. And we'll do that on our constructor as well. And that should resolve our errors for our chase state. And then we'll do this again for our attack state. So new file, attack state.cs. And we'll paste that in there. And we'll change patrol to attack. And we'll do that in the constructor as well. So that is going to create the files for all of our states that we're going to create in this video. And in order to create a new state, you'll do the same thing. You paste it in there, and then you'll add the behavior here once we go through how to set this up. Okay, so I'm going to go ahead and just close my attack and chase state for now because we're not going to use them. We're going to work on setting up our patrol first. So before we code our patrol state, let's go ahead and take a closer look at how we want our basic patrol state to function. So I'm going to head back over to Miro here so we can take a look at how this is going to work visually. So I'm going to scroll over here to where we have some waypoints set up. So our patrol state is going to work with an enemy that's going to be walking around our scene, and what they're going to be doing is walking between waypoints in a room or a hallway inside of our dungeon. So our waypoints are going to define the path that our enemy is going to take. So for a basic patrol, we're going to loop through our waypoints and visit each one, and then when we reach the last one, we're going to head back to our first waypoint. So our character might start at waypoint 1, and it's going to walk to waypoint 2. And we've got this backwards. We're going to flip that. Then we're going to walk from waypoint 2 to waypoint 3. And you can see that waypoint 3 is our very last waypoint. So instead of trying to go to a waypoint 4, which doesn't exist, we're going to go ahead and just say head back to waypoint 1. And let me move my enemy star here so we can create that transition here. And so basically what our enemy will do is He's going to start somewhere in the world. He's going to walk to waypoint 1. Once he gets here, he's going to walk to waypoint 2. Once he gets to waypoint 2, he'll say, I'm here, and I need to go to the next waypoint, so we'll head to waypoint 3, and he'll do that. And now, again, we're going to transition to our first waypoint by setting our current index back to 0 and heading back, so that way we move in a circle. For a path that only has 2 waypoints, this will look like traveling from waypoint 1 to waypoint 2, and then back to waypoint 1, and it will bounce between those two. But for any more than 2, we're going to end up traveling in a circle or triangle or whatever shape that might look like. So let's go back to our code and start implementing this. So in our patrol state, what we're going to need to be able to do is we're going to need to be able to move our player to our next waypoint. So let's start by adding a way so that way we can move our enemy. So I'm going to open up my scripts folder, and we have a player movement script already. So since we're going to be adding another movement script, let's go ahead and add a new folder, and we'll call it movement. And let's drag and drop our player movement into our movement script folder. And then inside of our movement folder, let's go ahead and create a new file and call it enemy movement.cs. And then we're going to just go ahead and create this class in here. So a public class enemy movement, and then this is going to inherit from mono behavior. So from the pop-up here, go ahead and select the one that says Unity Engine, and this will go ahead and import that for you in our using fields. And then we'll go ahead and add our curly braces to define our class body. So now that we've got this, let's add a function that we can call in order to move our enemy. So I'm going to create a function called move. So we'll say public void move. And because this is for our enemy, we're going to need to always move towards a specific point in space. So we should pass in a vector 3 so we can define where our destination is. Let's go ahead and say vector 3 and call this destination. Okay, so then we'll create our curly braces and we'll define our how to move. So for a patrol state, we're going to be moving between waypoints. And what we'll need to do in order to move is define a speed, a variable. So let's go ahead and do that up here. We'll say public float speed. And I'm going to set mine to 1 for now. This might be too slow or too fast, but we can adjust this in Unity later to decide what speed we want. So now let's go ahead and add our logic that's going to move our enemy towards the point that we defined. So there is a function that's already defined in vector 2 called move towards that we're going to be using for this. So this takes in a current vector, so that is where we currently are. So we'll pass in our transform.position for this. And it wants to know where we're going. So this is our target, and that will be our destination. So we'll say destination. And then our max distance delta, so all this means is how fast we want to get there. So how far can we move? Basically, each time we call update, essentially. So what we're going to do here is use our speed times time.delta time. So we'll say speed times time.delta time. Okay, so this is going to move our player, but we need to make sure that we're setting our transform position to whatever this spits out, because it does spit out a vector 2. It gives us the new vector moved towards that other vector by our distance delta. So let's go ahead and set our transform.position equal to that new vector. And you want to make sure that you don't do plus equals here, because this is going to calculate the new position where your enemy should exist. If we add that to our current transform position, it's going to like sprint across the map faster than you can see it, and it's going to very quickly error out. So make sure that you use a equal sign here and not a plus equal sign. So that's going to get us moving. However, we do have some overlap between our player and our enemies in terms of functions. So I think we can go ahead and refactor slightly to make our movement types a bit more decoupled and independent, and allow creating different types of movement very easy in the future. So let's go ahead and in our movement folder, let's go ahead and create a interface called iMovement. And then we'll say .cs. And this will be a public interface. And then iMovement. And inside of here, we're going to just define a single function, and this will be to move. So it'll be void move. And we already have this in our enemies. In our enemy, we need to know where we're going. So that's a vector 3 that tells us what position we're moving to. However, our player takes in a different vector 3, but still a vector 3. So this is important because we can actually take in a vector 3 for our enemy and our player in order to know where we're going. So you can see here that when we're moving, we're using a vector 2 to figure out which direction we want to move. So this is the input. So this is the direction we pressed on the keyboard. So left, right, up, or down, times our speed, times our delta time. And that is going to give us a vector to move towards, or to move in. So what we're going to do is for eye movement, we'll just use a vector 3 here for our direction. And I'm going to call it direction since that's what our player uses. But this is going to be okay because when we pass it in a destination for our enemy, it's still going to work. Okay, so let's go ahead and head back to our enemy movement script. And instead of just mono behavior, we're going to implement eye movement here. And this, you can see that this has created a different one. And that's because it decided that I was trying to use system.numerics in here. So if this happens to you, go back to your eye movement and delete this from here and using Unity Engine instead. And that's going to fix what type of vector it thinks you're trying to use. We can go ahead and delete this void out of here. And that will leave us with a proper definition of our move implementation from our eye movement interface. Okay, so next let's go ahead to our movement, player movement, and we'll also implement this. So we'll go ahead and after mono behavior, we'll say eye movement. And we will implement the interface. That's going to add our move down here. So in here, what we'll do is just grab our movement. So RB2D move position. We're going to cut that and paste it into our move function. And instead of movement here, we're going to use direction. And we'll need to downcast this to a vector 2. So that way it doesn't try to use a vector 3. It'll get rid of our error. And then when we removed it from here, we need to now call our move function and pass in our movement. Okay, and that's going to make sure that our player still moves. All right, so now that we have our movement here updated, let's go ahead and head back to our patrol and start implementing our patrol state. So at the top of the class, we're going to need some variables in order to complete our patrol. So what we're going to need is a reference to our eye movement. So we're actually able to get this from our owner. So let's go ahead and just create a private eye movement and call this movement. And then from our constructor, we can go ahead and say owner.getComponent. Then in here, we'll say eye movement. Okay. And then we're just going to go ahead and set our movement equal to that. Then we're also going to need to know which waypoints we need to use. And we're not going to be able to get this from our owner. So let's go ahead and allow our caller to pass this in. So when we create a new state, we'll pass in which waypoints we're using. So go ahead and create a private list. And this list of vector 3s is going to come from our dungeon generator when we decide we've generated a dungeon and now we're going to put an enemy in X room. It's going to create a list of waypoints for us eventually. But for this video, we're just going to pass in some random spots in the scene for testing. But eventually we're going to get vector 3s from our dungeon generation and take that in as waypoints. So we're going to go ahead and set this up as a vector 3. And we're going to call this waypoints. And then inside of our patrol constructor, we're going to go ahead and pass in those list of vector 3s for our waypoints. Let's say waypoints. And then after we set our movement, we'll say this dot waypoints equals a new list of vector 3. And then we're going to copy it from the waypoints that we've passed in. Okay, we're also going to need to know what our current index is for our waypoints since we're going to be looping through a list. So we'll create a private integer and call it current waypoint index. And then in our constructor, I'm just going to make sure that we set this to 0. And lastly, we're going to need to know how close we can get to a waypoint before we switch which waypoint we're walking to. So essentially, it's close enough because we're never going to be able to get exact. In a lot of cases, it's going to get very close to the position we want to get to, but never exact. So we need to give it a close enough value so that way it looks smooth. So when they get within a certain range, they'll switch to the next waypoint. We'll consider that we've reached the waypoint. So I'm going to go ahead and create a private float and call this close enough. And I'm just going to define this right inside of this class. So I'm just going to say 0.1f is close enough. And then let's go ahead and set up our movement logic. So we're not going to do anything on enter here. But what we can do is collapse it so we don't have to see it so much. So if you hover over on the side here, you should have a collapse button. I'm going to do that for my exit as well. And then inside of my execute function, we're going to need to move our enemy towards our waypoint. So let's go ahead and call movement.move, and then we're going to pass in the waypoint position. So we'll say waypoints, and then we'll use our current waypoint index to get the waypoint. Okay, so then we're going to need to check if we reached our waypoint. And if we have, then we'll go ahead and transition to the next waypoint. So first, we'll need to calculate the distance from us to the waypoint. So we'll say float distance to waypoint equals vector3.distance. And we'll use our owner.position and our waypoint. So we'll say waypoints, current waypoint index, to get the distance, and then we need to check if this distance to waypoint is less than or equal to close enough, because if it is less than or close enough, then we've reached our waypoint. So we're going to increment our current waypoint index by 1. So this means we're going to go to the next waypoint. Then we need to check to make sure that this index here is not going to be out of range. So if we have 3 waypoints, we're going to start at 0 index for our first waypoint, 1 index for our second waypoint, and we'll have a 2 index of our third waypoint. So if we got to our third waypoint and we increase it to 4, there's not going to, or increase it to 3, there's not going to be a 3 index. So what we'll do is we'll switch it back over to 0, so that way we end up going in a circle. So if current waypoint index is greater than or equal to our waypoints list.count, then we'll need to go ahead and set our current waypoint index back to 0. Okay, so this logic is going to allow us to move towards our current waypoint. Then we'll check if we've reached it, and if we have, we'll set the next waypoint. If we've reached the last waypoint, then we're going to go ahead and loop back to the first one. Okay, so now we'll need to create an AI controller to kick off the state machine and then keep track of the key items that we're going to need for our AI behavior, such as our waypoints. So let's go ahead and open up our AI folder, and we'll go ahead and create a new file. And I'm going to call this AI controller.cs. Okay, so let's go ahead and create our class. So we'll say public class, and then this will be called AI controller. And this is going to inherit from mono behavior because we'll need to put this as a component into our scene on our enemy. All right, so let's go ahead and define some variables that we're going to need in order to pull this off. So first, we're going to need to, for testing, define our waypoints for our enemies. So let's go ahead and create a public list of transforms. So that way we can just pull and drag them into our list, so we don't actually have to specify specific points by typing them in. This is going to make testing a little bit faster, but we will need to take this out once we have finished with testing and we get our logic for creating our waypoints inside of our dungeon generation. So that's for testing. And then we'll need access to our to a state machine. So we'll say private state machine. And I'm just going to call mine state machine. And this is what's going to change states and then also update states for us. That's just going to give, to separate out that behavior so we can reuse it in the future. And then we're going to create a private list of our waypoint positions. This will be a vector 3. This is going to we're going to calculate what the vector 3s are from our transforms and then put it in this list for use. So this is just going to help us with testing. So waypoint position. And then I'm going to equal that to a new list of vector 3. Okay, so next let's go ahead and set up a awake function so we can go ahead and get all of this stuff set up and ready for use. So we'll say private void awake. And inside of our awake function, we're going to go ahead and loop through all of our waypoints. So say for each var waypoint in waypoints. And so for each of these, we're just going to go ahead and add them to our waypoint positions list. So we'll say waypoint dot position. Okay, so that is going to get us our waypoints. Then we can go ahead and create our new state machine. So we'll say state machine equals a new state machine. And then we're going to go ahead and change our state to our patrol state. So we'll just pass in a new patrol state. And inside of here, we need to pass in the owner. So we'll say this dot transform. And then we also need to pass in our waypoints. And we're going to pass in our waypoint positions. And that is going to get us our patrol state. So now that we have our patrol state set up and we have currently entered it, we also need to make sure that we're calling that update function on our state machine so our patrol state will actually work. Because all of our logic for our patrol is in this execute function, and our execute function gets called in our state machine update function. So from our AI controller, we need to create a update function. So we'll say private void update. And then in here, we'll just say state machine dot update. And that will be it for our AI controller for now. And this is going to allow us to see our patrol. So let's go ahead and save all of our scripts, and then we'll head back to Unity to test it out. So in Unity, we'll need to add a couple of things to our enemy to make sure that it's set up correctly before we can test it out. So let's go ahead and click on our enemy. And we're going to add an AI controller to our enemy. And this will give us a list of waypoints here. So let's go ahead and create our waypoints for testing. So I'm going to create them as new empty game objects just in our scene. And I'm going to call them waypoint 1 through probably 3. So I'm just going to go ahead and rename all of these to waypoint 2 and then the second one to waypoint 3 here. Okay, and then we'll click on our enemy and we'll just drag these onto our waypoints list. So we can go ahead and say waypoint 1 and then drag waypoint 2 and then drag waypoint 3. And you'll see that this adds them in order to our list. So we're also going to need an enemy movement in order for us to actually move towards our waypoints. So let's go ahead and add that. So we'll say enemy movement. And I'm going to leave my speed to 1 for now. We could just see how that works. And if we need to adjust it, we can. And for our waypoints, I actually think that it's going to be kind of hard to see them in the scene right now. So one thing that we can do is either give them an icon, such as this, or we can go ahead and give them a sprite. So I'm going to leave them with these icons that have their names on them for now. But if this is too difficult for you to see, you can go ahead and just give them a sprite. Give them a sprite renderer, add a sprite, and then it'll be easier to see. And I'm going to move these around a little bit in my scene as well, just so the enemy has somewhere to walk to. So let's go ahead and add waypoint 2. And then our third one will be waypoint 3. And we'll just add this kind of over here. So you've got this little triangle for him to walk around in. And then I'm just going to drag my enemy over here so he doesn't have to walk so far to get to them. Okay, so that gives us our waypoints and our enemy all set up. So let's go ahead and save our scene, and then we'll go ahead and hit play to see our enemy walk from our current position here to our first waypoint. And then after that, it should walk from waypoint 1 to waypoint 2, from waypoint 2 to waypoint 3, and then once we get to waypoint 3, we should head back to waypoint 1. So let's go ahead and hit play. And this is going to make us switch over to our players. So we'll just click on our game scene and we should see our enemy moving to waypoint 1. When he gets there, you can see that he's moving to waypoint 2. All right, heading to waypoint 3. This looks great. And then from here, this is the real test because this is a risk for out of index. So if you get one of those, go ahead and just make sure that you review that code. But it looks like ours is going back to waypoint 1. And now he is going to bounce between these 3 waypoints until something changes his state from patrol. So we can see that our enemy is currently working and our patrol state is working. So next what I want to do is I want to take a look at how he's walking to his first waypoint from waypoint 3, because we can actually see that he is walking backwards to that waypoint. And that's because we're not updating his sprite to flip back and forth like we are for our player. So let's go ahead and update that so he does face where he's walking and it will look a little bit more polished. So let's go ahead and stop playing. And speaking of how our player already works this way, let's go ahead and open up our player movement script, because that is going to contain the key to what we're going to be doing. So we currently have this flip X function that handles flipping our transform, so that way our player flips the other way along with its sword and its bow. And anything that is attached to it as a child will flip with it. And we want that same behavior for our enemy because our enemy is also going to be able to attack. So let's go ahead and create a parent class for our enemy movement and our player movement that they can share, that will just go ahead and incorporate this flip X so that way we don't have to repeat code. So let's go ahead and open up our movement folder and we'll create a new file. And I'm just going to call it movement.cs. And in here, I'm going to declare the class. So we'll say public class movement. And this is going to inherit from mono behavior because it will be a component. And our player movement is no longer going to inherit from mono behavior because it's going to get it from the movement class, as well as our enemy movement. So let's go ahead and add that. And then this will also need to implement our eye movement. Okay, so let's go ahead and implement our movement interface. And then this is going to be a virtual void, so our children can go ahead and implement this however they see fit. So I'm actually not going to put any code in here because I don't want to handle it here. I want my children to be able to handle it themselves. And now what we can do is go to our player movement script and cut and paste our flip X from our player movement script and put that into our base class now. So in our movement script, we'll go ahead and paste this in here. And this is private, so it won't be able to get used from our player movement and our enemy movement. But we can go ahead and change it to protected, and then they'll be able to access it. So let's go ahead and update our player movement. First, we'll need to go ahead and change our inheritance and just change this to movement. And that's going to get the mono behavior movement from the parent class as well as the eye movement implementation. So now I've got that. And we have this redundant move here because this is actually hiding the move function from our parent class. So let's go ahead and just add the override keyword there, and that will fix that little warning. All right, so let's go ahead and update our enemy movement as well. So we'll go and we'll delete this and change it to movement. And then also make this override. All right, so now from our enemy movement, let's go ahead and close our Explorer. We can, after removing, let's go ahead and call flip X. And then we need to know which direction we're facing. So that's going to take in a Boolean. So first, before we call flip X, we'll need to calculate which direction our waypoint is from us. So which direction we're moving. So in order to do that, we can say vector 3. And we'll call this, see, I accidentally did this system numeric. So let's make sure we're deleting that. We don't need it. I do that every time, I think. Okay, so with that removed, we're going to call this direction. And then we're going to go ahead and set this to our destination minus our transform.position. And that will give us the direction that we need to move in order to get to our waypoint. And then what we'll do is we'll just check our X. So we'll say direction dot X is less than 0f. And that's just going to say, is the direction that we're moving in. If that X is negative, it means that we need to move to our left. And that means that we should face to our left. Okay, so let's go ahead and save that. And we can head back over to Unity and make sure that our changes have taken effect and haven't messed anything up. So let's go ahead and we need to test this on both our enemy and our player. So let's go ahead and hit play. And we're going to check our player first. So we'll make sure that we're still flipping and that when we use our attack, we're still flipping. Okay, so that looks like it's working perfectly. So now let's go to our enemy. And right now we can see he's facing right, but that's because his waypoint's on the right. Here we go. And he's flipped over, so now he is facing the waypoint he's moving to. Perfect. Okay, so now that we've got that, let's go ahead and stop playing and we will make sure that everything is saved. And then we're going to go ahead and start working on our chase state so that our player can get chased by our enemy once we get close enough to detect, but not close enough to attack. So this behavior is going to attempt to get close enough to attack the player. So let's go ahead and head over to our Visual Studio. And what we're going to do here is open up our chase state. So I'm actually just going to close all of our folders and files that are open. And we'll go ahead and open up our chase state. So let's go here. We'll click on our chase state. Here we go. And then we'll close that. Okay, so inside of our chase state, we're going to need to get everything filled out. So this state is going to be handling chasing the player. So once they've detected the player, they need to chase them in order to get into attack range. So for this, we're going to need to know where the player is so we can check if we're close enough to the enemy to be detected. So we'll need to add a reference to our player. So let's go ahead and create a private variable to hold that. So say private, and then we'll just do it as a transform, and then we'll just call it player. And then what we can do is pass our player into our chase state. So we'll add that here. So transform player. We're also going to need to get our movement in order for us to move. So let's go ahead and create a private variable for that. And we'll call that one movement. And we're going to get the movement the same way we did in our patrol state. So we'll say movement equals owner dot get component. And then we'll look for I movement. Okay. And then we'll set this dot player equal to player. All right, so now that we've got that, let's go ahead and set up our behavior. So for our behavior, we're going to need to move towards our player position because we're chasing our player. So let's go ahead and use our movement script inside of our execute function to chase the player. So we'll say movement dot move, and then we'll use our player dot position in order for our destination since we want to chase the player. Then the next step will be to add our transition from our patrol to our chase. So this is our entire chase function here. So let's go ahead and close that. And we're going to go ahead and open up our AI controller. And in here, we're going to add our logic from transitioning from our patrol to our chase. So after we update our state machine, let's go ahead and add a few spaces. And we'll check if our player is close enough to us to transition into a chase state. So to do this, we'll need to get our distance to our player. So we'll say distance to player. And I'm just going to put a semicolon after that because we actually don't have a reference to our player in our AI controller. So we'll need to go ahead and add that. So just after my waypoints, I'm going to say public. Well, actually, I'm going to do it before so it looks nicer in the inspector. Say public transform and call this one player. Okay, so save that, and then what we'll do is inside of our update, we'll go ahead and get our distance to our player. So we'll say equals vector3 dot distance from our transform dot position to our player dot position. Okay, so now that we have our distance to our player, we need to check if we are close enough to our player in order to transition from our patrol state to our chase state. So really what we need to do is define a detection range. So let's go ahead and create a public float and call it detection range just after our player at the top. And from here, we'll go ahead and go back down to our update, and we'll check that. So we'll say if distance to player is less than or equal our detection range. That means we have detected our player. So we can go ahead and change our state to our chase state. So we'll go ahead and say new chase state. And from here, we need to pass in our self. We'll say this dot transform. And we need to pass in our player. Perfect. So if we are not in our detection range, we probably want to go back to our patrol state. So we'll say else. And we'll say state machine dot change state to a new patrol state. And we'll pass in our transform. And then we'll need to pass in our waypoints. So we'll say waypoint positions. Okay, so before we go ahead and test this out, I do want to consider just one thing. If this is true, it's going to create a new chase state on update. So every frame is going to create a new chase state and change its state to the new chase state. So we actually really don't need to change it that often. We only need to change it when we have this transition from our chase to our patrol or vice versa. So what we can do is to our state machine, we can add a way to check if our state is currently a chase state or if our state is currently a patrol state. And that's going to save us some memory and some garbage collection as we're progressing. So let's go ahead and open up our state machine and we'll add a function to check if our current state is a particular state. So we'll say public bool is state, or we could say is current state. And then we're going to define a type here, and that's going to allow us to specify which type. So when we call this, it'll look like is current state, and then we'll be like chase state, something like that. Okay. So this is going to allow us to pass in which state we're trying to check against. So inside of our function, instead of calling that, we're going to return, and we're going to check if our current state dot get type, and then we'll see if that is equal to the type that we passed in. So we'll say type of T. And if this is true, then it's going to return true. And if it's false, it'll return false. So let's go ahead and save and then head back to our AI controller. And then inside of our AI controller, if distance is less than or equal to our detection range, we can go ahead and check if state machine dot is current state, and we'll check chase state. So if that is true, then we don't want to change to our chase state again. So what we'll do is just copy and paste that in there. And then instead of saying if it is true, we can add a exclamation point here. So this is the not symbol. So we'll say if that's not true, we'll go ahead and change it. But if it is already that state, we don't need to change it because we're already in that state. And then let's do the same thing for our patrol. So we'll say if not state machine dot is current state patrol state. So if that is not true, we're going to go ahead and transition to our patrol state, because we only want to go to our patrol if we're not already in our patrol. If we're already in the patrol state, we don't need to transition to it. Okay, so now that we've gotten that added, we can go ahead and we can test it out to see if our player transitions to our chase state after being in patrol. So let's go ahead and save our scripts, make sure everything's saved, and then we will go ahead and head back to Unity. So let's go ahead and do that. And then once we are in Unity, we can go ahead and really we can just save, make sure everything's saved, and then we can hit play. And then we're going to need to drag our enemy into our dungeon, since our player is inside of walls here. Our enemy is not going to be able to get to it, and we're not going to be able to get to them. So in our scene view, I'm just going to go ahead and scroll out, and then I'm going to select the enemy. And if you don't have these handles already, you can press W and they will appear. And then it actually looks like I've got an error here, and I think it's because we haven't set the player variable. So let's go ahead and just stop playing and remember to do that. Let's go ahead and add our player to our enemy. So yeah, so in our AI controller, we need to set our detection range. Let's go ahead and set that to 6. And then let's drag our player into that player spot. Okay. Okay, so now that we've added our player here, I'm just taking a look at our enemy here, and I think what's going to happen is when we pull him into our scene, he's actually going to be able to walk through our walls, and I think that's because he doesn't have a rigid body. So let's go ahead and just add one really quick to make sure that he can't walk through the walls and he can't escape the dungeon. And we're going to allow his type to be dynamic. Let's go ahead and change the gravity scale to 0, and then our rotation will freeze on the Z. And I think that's going to make sure he doesn't walk through our walls. So I just want to do this for safety measures so he can't get away from us. So let's go ahead. I'm just going to move this up so it's like with the Unity components, and then I'll collapse it. And now we can save our scene. And then if we hit play, now we have our player, our detection, and a rigid body added. Let's go ahead and press play. And then what we'll do is we'll drag our enemy into our scene. So in our scene, let's go ahead and grab him and then pull him into our dungeon. So now you can see that he's kind of stuck there. So now what we'll do is we'll take our player and we'll walk over. So let's go ahead and switch back to our game scene. And then we'll walk over to the room that the enemy is in. You can see that he's definitely chasing our player now. Okay, so I think what we should do is we should add a check to see, if our enemy is in close enough range to us that they can stop chasing us. Because at the current moment, he's just going to try to take this position that we're actually occupying. But with our attack, this should fix this because we're going to stop patrolling or chasing and we're going to immediately start attacking. So that's going to allow us to make sure that that doesn't happen. But it does look like our chase is working, so let's go ahead and just run out of range of our enemy to see if he goes back to patrolling. He's trying to patrol, but he's stuck, so it looks like that transition is working as well. Okay, so let's go ahead and implement our attack state now. So we'll go ahead and make sure everything is saved. We'll head back to our code. Okay, so now that we've got our attack state open, we're going to need to set up a couple of things in order for this to work. So since we are creating a attack state, we're going to need our combat. So we'll need to have a reference to that. So we'll say private. And because we added this as a interface, we can go ahead and just reference iCombat. And it won't matter if it's technically like a player combat or an enemy combat, it'll still work. And then I'm just going to name this combat. And then inside of our attack state constructor, we can go ahead and get that. So we'll say combat equals owner.getComponent. Then we'll say iCombat. And there we go. We have our combat set up. All right, so that gives us our combat set up. So let's go ahead and I'm just going to collapse my enter and exit functions. And in our execute, we're going to go ahead and call the attack function. So we'll say combat.attack. And because all iCombats have this function, it will work. However, this function gets run inside of updates. So we should make sure that our combat component can handle making sure that we can attack before we just attack. So let's go ahead and create an enemy combat script to handle our enemy attacking. So inside of our combat system, we'll create a new file. And we'll call this one enemycombat.cs. All right, so now that we've created that, let's go ahead and add our class. So we'll say public class enemy combat. And this is going to inherit our combat script that we created when we created a combat system for a player. And that is going to make sure that we inherit the iCombat and then all of the shared functions that each combat component will have. So let's go ahead and close our Explorer. And what we'll need to do is go ahead and override our attack function so we can do whatever we need to do when we need to attack as an enemy. So say public override attack. And we don't need to call the base attack, so let's go ahead and remove that and save. So now what we can do is just call the execute attack function on our attack type and perform the attack. So for this, we're going to need to pass in our transform, our attack damage, attack layer, and also if we're facing left. So in order to do that, we'll need to make some adjustments to our parent class and our player combat class. So the player combat has a function that will check if the parent is facing left, and it does that by checking the local skill on the X. So let me go ahead and open that so we can see it. So we have this is facing left function, and we can use the same method in order to do this on our parent so that our enemy also has access to this. So let's go ahead and open up our combat script. And in here, we're going to cut and paste the is facing left function into our parent script. So let's go ahead and inside of our player combat, which I don't think is open anymore. So let's go ahead and open that back up. And I'm going to go ahead and cut this function from here and save. And then I'm going to go into our combat script in here, and we're going to paste it in there. Okay, so then I'm going to take this private and I'm going to turn it into a protected virtual bool. So that way we can override it if necessary, but we probably won't need to override it for our enemy. But if we later decide we need to, it'll be available to override. Okay, so then inside of our enemy combat, we can go ahead and attack. So we'll say attack type. And then we'll make sure that this is not null before we try to execute our attack. And then we need to pass in our transform, our attack damage, attack layer, and finally is facing left, which should be available to us in our parent class. All right, so the next thing we need to do is specify which type of attack our enemy can perform. So let's go ahead and add some logic that's going to allow us to set up which attack we want to use in the inspector. So we're going to use a Boolean to tell us to use a melee or a ranged attack for testing. So we're going to come back and refine our combat system more later, but for now we're going to do what we did in our game manager, but inside of our enemy combat script. So what we'll do is at the top, we'll create a public Boolean, and we're going to call this use melee attack. Okay, and then if that is true, we're going to go ahead and create our melee attack. So we'll do this in our private void awake function. Okay, there we go. And then we'll say if use melee attack, then we'll go ahead and set our attack type equal to a new melee attack. And then for this, we'll need to pass in our attack range, and then a offset. So we'll say new vector 2. And then let's make sure we click on the Unity one so it doesn't automatically assume we're trying to use system.numerics. And then we will give it an offset. So we're going to give it the same offset as our player for now. So that was 0.5 on the X and 0 on the Y. And then it also needs a reference to our animator, which we don't have set up yet. So let's go ahead and add that null as a reference there. So now that we have this, we can go ahead and do the same thing, but for our ranged attacks. So we'll say else, and then we'll say attack type equals new ranged attack. Oop. And then inside of here, we need to pass in the prefab for our projectile. So we'll need a reference to that. So we'll say public game object projectile prefab. And then I think we're also going to need, I think that's it for that. So we'll go ahead and pass that in. So we'll say projectile prefab. We'll need our offset as well. So new vector 2, and this will be 0.5f and 0. And then we can go ahead and pass in a null animator. So because we're passing in a null into our attacks, we should make sure that we're going to handle the null value inside of our attack properly. So let's go ahead and I'm just going to command click on this. If you're on Windows, you can control click and it will take you to the class. So inside of here, we have our animator. So we're trying to set it up here. We've passed it a null reference. So our attack animator is going to be null. So before we can use it, we need to make sure it's not null. So next to our attack animator here, we can just add that question mark to make sure it's not null before we call set trigger. And that's going to make sure that that handles that. All right, so going back to our AI controller, our enemy combat, let's go ahead and click on the ranged attack and make sure that we do the same thing for our ranged attack. And that's just going to make sure we can handle any nulls so it doesn't cause errors when we're testing. All right, so now that we have that set up, let's go ahead and make sure that we have our AI controller set up properly. So I don't think we're going to need to add anything in terms of variables at the top, because we just need to get our combat through our attack, so that's fine. But we will need to set up a transition. So right now we're only detecting if our player is close enough to be detected, but we need to make sure that for our chase state we're not also in attack range. So we'll say and distance to player is greater than, and then we're going to need a reference to our attack range, which we can get through our iCombat. So let's go ahead and get that. We'll create a private variable, iCombat, and we'll call this combat. And inside of our wake function, before we get our waypoints, we can go ahead and grab this. We'll say combat dot so equals to transform dot get component. Then we'll say iCombat, and that will give us what we need. So then down here, we can say combat dot attack range. All right, so now that is going to make sure that we are only transitioning to chase if we are also outside of the attack range, but we are inside the detection range. And then for our attack, we'll add an else if, and we'll say distance to player is less than or equal to our detection range, and our distance to player is less than or equal to our combat dot attack range. So this is going to handle our transition to attack. So then we'll check if our state machine does not already have the current state of attack. Then we can go ahead and transition to that. So we'll say state machine dot change state, and we'll say new attack state. And I think all this needs is our transform. So we'll say this dot transform, and that will get us into our attack state. So now when we get close to the player, they should try to chase us, but then once we get inside their attack range, they should attempt to attack us. So this is actually going to cause damage on our player if they hit us. So that will be our way to tell if this is working. So let's go ahead and save all of our scripts, and then we will go ahead and head back to Unity to give this a test. Okay, so back in Unity, let's go ahead and set up our enemy. So we're going to need to add a enemy combat, so we'll do that. And we're going to need to set up our attack range. So if we're going to use a melee attack, our attack range is going to be 1. And our damage, we'll say, is 10. And then we need to attack on the player layer. So we actually don't have that set up yet. So let's go ahead and we'll click on the player. We'll click on layer. And we're going to go ahead and add a new layer. And I'm going to call this one player. And then we'll go ahead and save our scene. And then we'll click on our player again. And then we'll make sure that that gets set. And yes, we'll change the children. Okay, we'll go ahead and save again. And then clicking on the enemy, we'll finish setting this up. So we'll say our attack layer is our player. And then we're not going to worry about our projectile right now, just because we're going to test our melee combat first. So we've got that. Let's go ahead and hit play. And then we'll need to drag our enemy into our dungeon. Okay, and then we'll switch back to our game, and then we'll go get close enough to chase. So he's trying to chase us. And then he goes back. Okay, so now we can let him attack us. And you can see that he is attacking us, and now we're dead. So our attack took place in like 10 frames, which is very, very fast for us. So we went from alive to dead in like less than a second. Okay, so let's go ahead and set up that attack delay so that we make sure that our player doesn't die immediately within just 1 second. So let's go ahead and open up our combat parent script, which is going to allow us to add the delay to all of our children so we don't have to set it up every time. So inside of here, we're going to add our attack range. Just right underneath, we're going to add our delay. So we'll say serialized field, private float, and we'll call this attack delay. Okay, so now we can go ahead and add a protected variable for our last attack time. So we can save when we last attacked versus now, and we can see if that is longer than our attack delay. And if that's true, then we can go ahead and attack. So after our private variables up here, we'll say protected float, and then this will be last attack time. Okay, so then with that, we can go ahead and save, and then I'm actually going to close my Explorer and head over to my enemy combat script. So let me go ahead and open that. So inside of our enemy combat script, we're going to use the new time to figure out if we should attack. So inside of our attack function, we're going to go ahead and get the current time. So say float current time equals time.time. So that's going to be the current time. And then we'll check if our current time minus the last attack time is greater than or equal to our attack delay. Yes, we made that private. We actually need to make it protected. I apologize. So here, instead of private, it will be protected. But I want it to be serializable, so we can set this in the inspector. Okay, so now that that is protected, we should be able to access it. So with it accessible, we can go ahead and add our logic. So if our current time minus our last attack time is greater than or equal to the attack delay. So if it's been longer than however long we said we would delay our attack, we can go ahead and execute our attack. Okay, so we'll paste that into the if statement. And then we need to make sure that we set our last attack time equal to our current time so it updates. That way, after this attack, we have to wait that amount of time. If we forget to do this step, we'll just be able to continuously attack very, very fast after that first attack. So we only have to wait for that first attack. Okay, so now what we can do is save this and head back to Unity to set up our delay. Okay, so in Unity, we should now see that we have an attack delay, and I am going to set this up to 2 so that our enemy can only attack once every 2 seconds. All right, and then we can go ahead and hit play, and this is going to allow us to test it. So let's go ahead and hit in our scene. We'll grab our enemy, we'll drag him closer, and then we'll go back to our game, and then we'll walk over to our enemy. So that is not the way. Nope. Okay, here we are. So there's our enemy. Let's let him attack us. So you see he did it. We have 2 seconds, and then he did it again. And now he's waiting 2 seconds to attack. So you can see that he's chasing us. So attack to chase is working. And then if we just run really fast, we should be able to see that he has gone back to his thing. He's trying to get to his waypoint. Yeah. Okay, so it looks like all of our transitions are working now. So that was fantastic. All right, so now that we have all of our transitions working, we need to consider the fact that it doesn't look like our player is being attacked by the enemy. And that's because we don't have any of our animations set up. So let's go ahead and set them up. And this will be really easy since we already did this for our player. So I'm going to go ahead and in my scene, I'm going to go ahead and open up and copy the sword and bow from our player. So we'll say copy. And then on our enemy, I'm going to right click and I'm going to say paste special, and I'm going to paste them as a child, keeping their local transform. So that's going to make sure they're positioned correctly next to our enemy. Okay, so we've got our sword and we've got our bow and we've got our enemy. So we've got all that. So our sword and our bow is going to come already set up with the correct controllers and everything. So all we need to do now is get the controller from our enemy and make sure that we pass it into our attack when we attack. So let's go ahead and open up our script. And inside of our enemy combat, instead of passing in null, we'll say find, and this will be sword. And then we'll say get component and animator. And that will get our sword animator for our melee attack. And for a ranged attack, we'll use the same. So I'm going to copy and paste this. And then we'll change the word sword to bow. And this is going to make sure that our animations are going to be working. So let's go ahead and we'll go back to Unity. And then we will go ahead and try it out. So let's grab our starter scene. We'll grab our enemy. And we'll drag him over to our dungeon. So here he is. And then we need to walk over to him. So here's our enemy. We can see that he's chasing us. Now he's attacking. So he's attacking using the melee. So we can see that he is using the sword animation. Okay, so let's go ahead and stop playing and we'll set up our projectile animation now. So on our enemy, we can go ahead and uncheck the use attack, melee attack, and then we need to give it a projectile. So let's go ahead and drag in our projectile from our prefabs. Oops, so click on our enemy and we'll just drag in our projectile. Okay, so let's go ahead and hit play. And what we should see is that our enemy does try to attack our player. So let's go ahead and drag our enemy into our scene. And then we'll go ahead and walk near him so he can try to attack us. And then he's not going to do this until he's really close to us. So I'm going to actually make his attack range a lot larger since it is a ranged attack. And this will make it more clear that he's shooting us. I did see the bow animation play, which is positive. So grab him, just put him over here. And then in our game scene, we'll walk over to him. So we can see he's shooting, but the arrow isn't doing anything. So let's just get him. So it looks like his arrow might be actually hitting him because I'm seeing that the enemy is taking damage in our console. So that's not positive. That means that our projectile is actually hitting him because it's on the wrong layer. So if we go back to our projectile, we can see that its target layer is enemy. So what we need to do is set up a projectile for our enemy that is on the correct layer to hit our player. So let's go ahead and duplicate this and then we'll rename it enemy projectile. And we'll go ahead and we'll drag that onto our enemy instead of our player projectile. So let's do that. And then let's go ahead and set up the correct layer. So instead of enemy, we're going to say player, and we'll make sure that we uncheck enemy. And now when we hit play and try out, it should work. So let's go ahead and drag our enemy over to us. Okay, and then we'll just run over real quick. And now we should see that our enemy is not getting hit with it, and instead our player is now taking damage. So another thing that I noticed while testing was that if the enemy was in the attack state and the player moves to the other side of the enemy, that the enemy does not flip to face the player. So let's go ahead and see this. So we'll grab our enemy and we'll drag him into our dungeon, and then we'll go ahead and run over to him. Okay, so I'm going to move below him. I'm actually going to pull him out this way. So if I flip to this side of him, he still shoots to the right instead of facing my player to try to shoot my player. So let's go ahead and fix this. So I'm going to stop playing and we'll go ahead and save our scene. And then we're going to go over to our scripts and we'll open up our eye movement because we're going to need a way to tell which direction we're facing and so that we can set it, which is kind of what we're doing with our flip X, but we need a way that is central to all of our movements. So that way I can call it on any type of movement. So let's go ahead and open up our eye movement. And inside of here, we're going to add another void. We're going to call it set facing direction. And we're going to pass in a Boolean and we'll say is left. Okay, so this is going to cause some errors inside of our enemy and our player movement because we aren't implementing that anymore. So inside of our movement, we're no longer implementing this. So we'll go ahead and implement our interface in our movement. And then what we'll do is we will make this a virtual void so we can set our direction. So let me go ahead and close that. And we'll say virtual. So that way if we need to overwrite this, we can. But in here, what I want to do is just call flip x. So that way it's internal. So we'll say is left. And this will go ahead and set our current facing direction. So with that done, let's go ahead and open up our enemy movement script. So go ahead and select enemy movement. And instead of calling our flip x, we're going to go ahead and call set facing direction. And we can just leave that Boolean in like that. And then what we'll do is we'll also do this in our player movement. So that way we're uniform here. So we'll say set facing direction. Okay. And then finally, we're going to have to use this from our attack state. So let's go ahead and open up our attack state. And what we'll need to do is we're going to have to pass in our movement into our attack state. So let's go ahead and close all of these tabs because it's starting to get hard to find the things that I'm looking for. So go ahead and close everything that is not my attack state. Okay, here we are. And inside of here, we're going to need to get our movement. So let's add a private I movement. Okay, and we'll call this movement. And we'll go ahead and set this up in our constructor. So we'll say movement equals owner.getComponent, and then we'll say I movement. Okay, and we're also going to need to know where the player is because we're going to need to tell if they're on the left or right side of us while we're attacking. So we're going to go ahead and pass in our player transform into our constructor. And then we'll also save this into a private variable. So transform, and I'm going to call this player. And then after we get our movement, we can go ahead and say this.player equals player. Right, so that is going to set up our movement and our player. So now we can actually go ahead and use these things in order to perform the action that we're wanting to do. So let's go ahead and figure out which direction our player is compared to us. So we can go ahead and create a float. We'll say direction to player, and this is just going to be on our X because we don't really care about Y because of how our player and our enemy can move. So our enemy and our player only face left and right. They don't face up or down. So when we're moving up or down, we're just going to continue to face either left or right. So we're only going to care about the X when we're checking the direction to our player. So let's go ahead and do that. So what we're going to do is we're going to get our player.position.x, and we're going to subtract our owners.transform.position.x from it. And that's going to get us the direction to our player only on our X. And then inside of our movement, we need to set our facing direction. So we'll say movement.set facing direction, and we'll say direction to player is less than 0f, meaning that the direction to our player is negative. That means that we need to face left. Okay, and then we'll go ahead and just attack like we were. So let's go ahead and update our constructor when we're creating this in our AI controller. So we'll need to open up our AI controller, and we can see that this is now not going to work for us. So we'll need to actually pass in our player as well, and that should resolve our error. So let's go ahead and save the script, and we'll head back to Unity to test it out. So I'm going to go ahead and clear my console, and then we'll go ahead and hit play. And we'll need to move our enemy into our dungeon. So let's go ahead and do that. So just put it over here. So our enemy is actually going to be going after a player immediately. So what I need to do is drag him out here a little bit and then run underneath him. And now we can see that he flips, which to the direction that our player is facing. So he will now try to face us and try to attack us on the correct side. All right, cool. So now another thing that I'm actually seeing, and I should not have hit play there. So let's go ahead and I'll show you what I mean, is that our enemy doesn't actually try to line up any of our attacks. So let's go ahead and go over. So I'm going to come up here, and he's just going to try to shoot me from there because he's in range. He's within 3, but he's not lined up with my player. So he's actually not going to hit me ever from here. So what we want to do is make him a little bit smarter and try to get onto the same Y position as our player. Okay, so to do that, we're going to go ahead and open up our, go back to our script. So we'll save our scene and we'll head back to our script. And we want to go into our attack state so we can set up adding the information and logic that we need here in order for us to line up our shot. So what we'll do is after we've set our facing direction, let's go ahead and check the distance between us and the position that we need to move to in order to line up our shot. So I guess first we really need to calculate what that position is. So let's go ahead and create a vector 3. And we'll make sure that we're using the Unity version. And we're going to say move position. And that is going to be where we should go in order to line up our shot. So in order to line up our shot, we will keep our X position because we don't want to move left or right. We want to move up or down. So we'll say new vector 3, and we'll say owner dot position dot X. And then we'll use our player's Y as our Y position. So say player.position.Y. And I just realized we don't actually need this transform here. So I'm going to go ahead and delete that so it's a little bit cleaner. All right, so now that we have our move position, we need to figure out what direction we need to walk in order to get to it, and then walk to it. So for our enemy, we could just set this as a position as our move because we're already doing that. We're handling that in our enemy movement. But we also need to define a close enough value. So when to stop moving, like when are we good enough to start shooting? So let's go ahead and create a flow, and we're going to call this close enough. And I'm just going to set this to the same thing that I set it in the other class. And this is going to allow us to change it if we need to, but this is going to be an internal value. And if you like, you can actually set this up to be passed in here, which is probably something we should do. So we'll do that next. Anyway, but after we get our close enough, we can check if our distance to our position that we want to move. So let's go ahead and say vector 3 dot distance, and we'll say owner dot position, and then we'll say move position as our second. So if that position is greater than our close enough value, then we're going to go ahead and move. So we'll say movement.move, and we'll pass in our move position. So this will tell us, hey, if we're not at our lined up shot, go ahead and move until we get lined up. And then this combat.attack is going to attack in the meantime. So the enemy likely will shoot while they're moving. So I actually like that behavior, so I'm going to leave it like this. But if you don't like that behavior, you can put this into an else statement. So you can say, we're not going to try to attack unless we're lined up. And in that case, we can add it like this. However, I don't want to do that. I want them to shoot as they try to get closer, just for right now. So I'm going to leave it how it was. Okay, so let's go ahead and save and head back to Unity to give everything a test. So inside of our editor, I'm going to go ahead and clear my console, and then I'll press play. Okay, and then we'll need to drag our enemy into the dungeon. So here we are. We'll drag him over here, and then we will have to go find him. So we're going to run over to the room he's in. All right, there he is. So now what he's going to do is he's shooting, but he's trying to line up his shot the best that he can before, taking that shot. So he might shoot as he's trying to line it up, but ideally he's gonna line it up. He's gonna line the shot up so he can get the shot with the player. So that makes him just a little bit smarter, and it's going to make him feel a little bit more difficult to have combat with. Okay, so there's actually just one more thing that I wanted to address before we get off today, and that is our enemy can currently shoot through walls. So if we go ahead and we go like, trying to get him to get closer. Okay, we go like this. He's stuck on the wall, so we'll drag him back this way. Just get him like this. Okay, so now he's actually behind the wall, so he's going to try to shoot me through the wall, and it's actually working. He's hurting me through the wall. So this is not okay. And this is simply happening because our projectile does not have the wall on its layer for attack. So what we can do is we can create a new layer for our walls. So let's go to our layer in our inspector, add a layer, and then we'll create this walls layer. Okay, and then what we'll do is once we have that, we can go ahead and click on our grid. We'll expand it to find our wall tile map, and then we're going to set our wall tile map on our walls layer, and that's going to set all of these walls onto that wall layer. And so when the projectile hits it, once we set it up, it's going to delete itself upon the wall, and since the wall doesn't have a health component, it's not going to apply damage to the wall. So let's go ahead and we'll save what we have so far, and then we'll go into our prefabs to our projectile, and we'll click on it to get the inspector, and then we'll set its target layer to player and then also walls. And we need to do the same thing for our player's projectile. So we'll say enemy and then also walls. And then now when we hit play, we should see that we're no longer able to shoot through the wall. So we can test it for ourselves. So let's line up with a wall. And I press it, it goes to the wall, and then it deletes itself. Okay, so let's actually get our enemy into our scene now. So, like here, and then he's going to try to shoot me, but if I can get him between the wall, so I'm going to come this way. Oh yeah, he's not. Okay, let's go. Pull him this way. So say, come on, get him in. Okay, so now he's going to be lined up with me. He's going to try to shoot, and he's not going to be able to hit me because it's going to delete when it hits the wall. However, this behavior is not like ideal either because now he's trying to shoot at me through a wall. Technically, he should not be able to see me. So in a future video, we're actually going to give them some real senses and like a cone of vision and a line of sight. So there you have it, an enemy AI system that is both functional and flexible. So you have created a fully implemented finite state machine. You have created core states like patrolling, chasing, and attacking, as well as a foundation for easily adding new behaviors and transitions. So test it out in your game, tweak the logic, and watch how your enemies come to life in dynamic and exciting ways. If you found this video helpful, don't forget to like, subscribe, and hit the notification bell so you don't miss the next episode. In our next video, we're going to take the system even further by adding AI navigation using A-star algorithm in order for our enemies to traverse our dungeon we create. If you have any questions or ideas, please drop them in the comments. I'd love to hear from you. Until next time, happy coding and keep creating awesome games.